MLOps engineer job demands are increasing day by day because of a boom in AI ML field. Hence, the salaries of MLOps engineer are also attractive. If you are willing to upgrade your skills to become an MLOps engineer, then this video is for you. In this video, I'll be explaining things from scratch and we will see actual demos. By the end of the video, you will have enough knowledge to start your MLOps journey. I'm going to cover many interesting aspects and demo in MLOps lifecycle, such as introduction to MLOps, basics of MLOps, installing and starting MLFlow Tracking server, and we will create our first MLOps project experiment. We will create a model, we will validate it, and we will do model registry and tracking. So watch this video till end to make most out of it. So without waiting much, let's get started. If you don't know about MLFlow yet, so this is the official website of MLFlow, that is mlflow.org. So what MLFlow is, it helps in build better models and generative AI apps on a unified end-to-end open source MLOps platform. As by its definition, it helps us building model and to create generative AI apps, and how it is helping us to build models by providing a platform which helps in end-to-end development of your ML application. So using MLOps, like you can complete the whole life cycle of your ML application. As of now, the latest version of MLFlow that is available is 2.19.0. It provides visual representation, various experiments that you will be doing, and there are many users around the world of MLFlow: Microsoft, Meta, Toyota, Booking.com. So these are really big names which are using MLFlow, so you can understand like how important or how trustable MLFlow is. So using MLFlow, what you can do is you can do experiment tracking. You might be doing different experiments on the model and you can compare them. So you can do all those tracking using MLFlow. You can get visualization of those experiments. It can help in generative AI, observability, evaluation of your models, like which one is working well, and the creation of model and storing models, just like we have registry for Docker images, so similarly we can have registry for models, and then serving your ML app. So what's the benefit of using MLFlow? So MLFlow is open source, integrate with any ML library and platform, so that's one of the big point. Because if it is open source, like many contributors or community members are fixing issues on proactive manner, you can get support from the community, and it is integrating with any ML library and platform, so you can imagine like how supportive this is. It is comprehensive, manage end-to-end ML and Gen AI workflows from development to production, so it will help you throughout the life cycle of your ML application. It's unified platform for both traditional and Gen AI application. So there are various use cases where you can use MLflow. For example, generative AI, improve generative AI quality, enhance LLM observability with tracing, build application with prompt engineering, track progress during fine tuning, package and deploy models, securely host LLM at scale with MLflow deployment. So this MLflow platform is helping in generative AI field with these features and functionalities. And if we talk about deep learning, it helps in native integrations with popular DL frameworks in use in the industries. For example, PyTorch, TensorFlow, Keras. It is simple low-code performance tracking with auto logging, state-of-the-art UI for deep learning model analysis and comparison. So like you can compare different experiments and you can see the visualization. And if we talk about traditional ML, end-to-end MLOps solution for traditional ML, including integration with scikit-learn, XGBoost, PySpark, and more. And again, autologging is there, and the UI model analysis for comparison. You can easily evaluate different experiments and different runs. You can evaluate different prompts, compare performance against a baseline to prevent regressions, simplify and automate performance evaluation, You can also do model management, for example, packaging model for production, including code and dependencies, catalog, govern and manage models version, orchestrate model rollouts to staging and production, deployment models for large scale batch and real time inference. So you can run MLflow anywhere. It has various integration, for example, with Databricks, any cloud provider, your data center, or maybe your computer. You can run things locally as well. We will be seeing like how we can run in different data center or cloud provider, or we will also see how we can run it in our local computer. And as I told you before, MLflow integrates with 25 plus tools and platforms. So like I already took some name before, like PyTorch, XGBoost, Keras, Spark, OpenAI, and so on. And there are various learning tutorials available, but you don't need to worry about this. I'll be covering many things. So stick with me. I assure you, you will learn most out of my videos. And after completing this, I'm sure you can call yourself an MLOps engineer or AI ops engineer. So we have seen what MLflow is. Now what we are going to do is we will cover some basic concepts around MLflow, which will help you to actually kickstart your journey in the practical world. So let's start without wasting any time. So first of all, I'm going to tell you what I'm going to cover. So for example, like what all components are there of MLflow and why we use MLflow and who are the stakeholders who uses MLflow. For example, data scientist, MLOps engineer, what will be their role? And finally, we will discuss about the use case of MLflow. So if we talk about the life cycle of DS project, so we have data preparation and then we do exploratory data analysis. And from that, feature engineering is performed. And then we do some training of the model and then we validate the model and then we deploy the model. And after that, we do monitoring around it. So during this life cycle, many stakeholders are also involved. So for example, the data governance officer will be involved throughout this process, right from data preparation till monitoring. And it's a never ending process. So he will be involved everywhere. Now, data engineer is involved in data preparation, collecting data, like it can be ETL pipeline. So data engineer is responsible at the very first phase of this life cycle. And then comes the role of data scientist. So data scientist helps in exploratory data analysis, feature engineering, model training, model validation. During model validation, MLOps engineer and business stakeholders will also be involved to validate the accuracy of the model. So some steps may involve collaboration between different stakeholders and some steps could be independent. Since we are also interested here in ML engineer role, the ML engineer will also be somewhere responsible or somewhere taking part right from the step 0 till monitoring. So it's like a collaborative engagement that should be there. But yeah, to differentiate the main role, MLOps engineer will be responsible from model validation till monitoring. Now let's talk about all the roles individually. First of all, we talk about data engineer. So data engineer will be responsible for data preparation and it can be through ETL pipeline. So we have already discussed what an ETL pipeline is: extraction, transform, and load. So we have already discussed that. So data engineer can take data from different sources, from different kind of databases, and then prepare the data using ETL pipelines. Now let's talk about data scientist. So data scientist can use MLflow for experiment tracking and hypothesis testing. So there can be different experiment that can be performed to check if the model is performing well and if the hypothesis that has been suggested is working well with the given parameters. So all these kind of tracking and experimenting can be done using MLflow, and data scientists can leverage MLflow for this. And also for code structuring, model packaging and dependency management. So your model may require different packages, it may have different dependencies. So data scientists can use MLflow for model packaging and also for dependency management. Another thing is evaluating hyperparameter tuning. So for example, like one can train the model using different parameters and then tune those parameters and visualize the results and then compare them All this comes under hyperparameter tuning. And then finally, compare the results of the model training over time with different parameters. So one can say like this model performed well and is very much accurate. Now let's talk about MLOps professionals. MLOps professional can manage the life cycle of trained models in both kind of environment like pre-deployment and post-deployment environment, and deploy the model security to the production. And MLOps engineers are also responsible to deploy the models securely on production environment. And then also that helps in managing the deployment dependencies and monitoring around it. This will be the role of MLOps professionals. Now let's talk about prompt engineering users. So what prompt engineering users can do, they can evaluate and experiment with large language model, also known as LLMs, and they can also create custom prompts and experiment around those. And then finally, like they can decide the best model that will be suitable for the project requirement, and based on that they will decide like which model is more suitable and that can be used. Now let's talk about the use cases. So you can do experiment tracking with MLflow, track different parameters and metrics. You will also get a great UI and you can visualize the metrics, and you can compare different experiments, and based on that you can finally decide which model is the best, and then you can deploy that model. And after that, once it is deployed, you can monitor the model performance. So MLflow is ultimately helping us in a collaborative way to manage the project. So I hope by now you have a fair understanding of different stakeholders and the use cases, and how different stakeholders are responsible at which phase, and how they can leverage MLflow to achieve their goals. So now we have seen what MLflow is and its use cases and the stakeholders, and how the stakeholders can use MLflow. Now is the time we should get our hands dirty with some real examples. So let's see how we can actually get started with MLflow. But before that, I would like to show you Conda. So Conda is a powerful command line tool for packaging and environment management that runs on various OS like Windows, Mac OS, Linux. So we will be managing virtual environment and packages and dependencies using Conda. So let me show you how you can install it. So you can install Conda on various OS like Windows, Mac, Linux, and here is the installation guide for various OS. Right now I'm using Mac OS, so I'll specifically go over this one and show you how you can install it. To install Conda, you need to get this particular file for ARM64 because I'm using M2. So this is the repo. Once it is downloaded, we need to make it executable using the command chmod +x, and then we are going to run this, and we need to review the license, so press enter to continue. And these are all terms and conditions, so you just need to press enter to read it full. I'll keep on pressing enter. You can type yes to accept the license terms. Once this is done, it is asking for the path to be set. Miniconda 3 will be now installed into this location, that is the home directory of my user. And if I want to confirm like this location is okay for me, I need to press enter. Otherwise I can press Ctrl C, or I can manually specify any other location. So I'm okay with this location, so I'm just pressing enter. Okay, the installation is done, and as you can see it has modified .zshrc file as well, because it must have updated the path. Now since it has updated the zshrc file, I need to source it again in order to make it effective. So I'm just doing a source command, and after that we should be able to have conda command available. So now conda command is available, and it is recommended to update the conda after installation. So you can run the command conda update conda. So as you can see, there is a patch available, so it is going to update that. So I'm saying yes, and now let's again run the version command and see the patch has been applied and the latest version is 24.11.2. So now we have the conda available. Now we can go ahead and continue our setup of MLFlow application. We are going to create the folder for our MLFlow application. So here is my MLFlow folder. I'm just going to get inside it, and here I'm going to create a virtual environment. So why is that needed? Because there might be different version of Python and packages available on different system. So for example, we are writing the code here on my local system, but when I'm going to deploy it on some remote machine or somebody else is going to run this project, they might have different version of Python or other packages. So it might conflict. We are developing with one specific version of the packages and other system may have different version of the same package. In that case, there might be a conflict and the application may not behave same. So which is why we should always have a similar environment available everywhere. For this, we are going to create a virtual environment, and within that virtual environment we will have all the dependencies installed. So even if somebody else is using it, then they can use that specific virtual environment and there will be no conflicts. So using conda, we are going to create a virtual environment. So the command is conda create -p venv, and the Python version we are going to use is 3.10, and we are going to say -y. So as you can see, within this virtual environment, it has created required folders, and as you can see, it is also suggesting us to activate this environment. We can use this particular command conda activate, and we can activate this particular virtual environment, and to deactivate we just need to run conda deactivate. So what I'm going to do is I'll just run the conda activate command. Let me copy it from here. Okay, now we have activated the environment. Now since this is done, what I'm going to do is I'm going to create a requirement.txt file. I can simply install packages using pip, but there will be no record like what all packages I have installed. So which is why it is necessary to have a requirement.txt file, so that all the requirements related to this project will be listed there, and anybody can use that requirement.txt and have the same version and the same packages available to run it on their system. So let me create the requirements.txt file. So this is the file, and I'm using Copilot. You can use Copilot in your Visual Studio Code, and this will be really helpful. And if you have not watched my video about how to use Copilot and what are its uses and how it can be useful, then I suggest you to please watch that, because that will be extremely helpful and productive for you. So here I'm going to first of all specify very first dependencies, that is MLFlow itself. So we'll be installing MLFlow package, and to install this we need to run the command pip install -r requirement.txt file. So it is going to install the latest version of MLFlow, because we are not specifying any specific version here. So let us go ahead and install it. Okay, now so MLFlow package is installed now. So now we have requirement.txt and our project setup in a virtual environment. So now we are going to create MLFlow tracking server. Within this MLFlow, I'm going to create a file. Let's give it a name, main.ipynb. So this is going to be a Jupyter notebook, and we will talk about MLFlow tracking server. So see, the auto completion is happening here because of Copilot. So guys, as you can see, when I'm actually running it, it is saying install or enable suggested extension Python plus Jupyter, or you can browse marketplace for kernel extension. If you get similar error, all you need to do is install ipykernel, which you can do using the pip command, pip install ipykernel. So this is not really required to be written in requirement.txt file, because it all depends on your installation of Python plus Jupyter. So I'm just going to install it. Okay, now let us try to run it again. First of all, let us save this and let's try run it again, and it is again asking, so I'm just going to select that. It is also trying to install Jupyter extension and Python extension. So this can also be specific to your Visual Studio Code, and you can install it using this way as well. Okay, this is installed now. Let's try to run it again. And it says which kernel source we want to install. So either using Python environment or using existing Jupyter server. And here I'm going to use this virtual environment Python 3.10. It is connecting to the kernel VNV, and now it is executed. Now what we are going to do is we will enable MLFlow UI. So I'm just going to launch another terminal, or I can just simply split the terminal, and here I'm going to run MLFlow UI. Okay, it says MLFlow command not found, because I need to again enable the virtual environment in this particular shell as well. It is already activated in the shell on the left hand side, but it is not activated here. So let us go ahead and activate the environment here as well. Okay, now it is activated. Now I will run the MLFlow UI command again, and now you will see it will be working. So now it is running on localhost and port 5000. Let us go ahead and hit this particular endpoint of localhost with port 5000 in the browser. And as you can see, it is running MLFlow 2.19 version. Here we don't see any experiments, any run, any evaluation, traces. Okay, we don't see any request ID. So everything is blank as of now. If you go to models, we don't have anything available here, no model available and no experiment available. So this is just a UI which we are seeing now. Okay, great. So we have our MLFlow tracking server up and running. Now what we are going to do is we will start writing some experiment. So first of all, we need to import MLFlow. After importing it, we need to tell where is our tracking server. So we are going to use MLFlow .set tracking URI. And again, as you can see, it is auto suggesting me to set the tracking URI first, and it is also taking some path, right? And that's the correct part because we are running it over localhost. So I'm going to press tab and it is autocomplete. Let's just run it. Okay, this is also set now. Now we are going to create an experiment. To create an experiment, I am again going to use MLFlow dot set experiment, and it is auto suggesting me, but I am going to change the name to say test tracking server. After that, I am going to say with MLFlow dot start dot run. As you can see, like it has auto completed a lot of things. So let us go through all these one by one. So with MLFlow, what we are saying is we are asking it to run this experiment with following parameters, metrics, and artifacts. For example, we are going to log the param. This is my parameter 1, and I'm giving it some value 5. Then I'm going to log a metric, say foo, and giving it a value 1, and I'm again logging the value of foo to 2. And then let's change this variable name to bar and give it a value 3. And again, let's try to MLFlow log metric, and let's give the value of bar to 4. Now we can also log some artifact. So we are just creating a text file, experiment1.txt and experiment2.txt. Okay, now we are done with our experiment writing. So we are going to just run it now. Okay, now it has run, but it has given an error, like it is not able to log this artifact because we don't have this file available, experiment1.txt and experiment2.txt. But nevertheless, what we have is the experiment is actually available at this particular endpoint. So let us just copy this and go to this particular URI, or also like we can just refresh this and we can see the experiment is available here, test tracking server. If I click on this, we will see all the details of this experiment. And one more thing to notice here is it was a particular run, like this is an experiment and for the first time I have run it. So for this first run, it has given it a name, enthused purge 351. So this is the name of this particular run. If I run it again, the name will be different. So all the runs will be listed here. So let's click on this, and here you can see all the details: created at, created by, experiment ID, run ID, duration, how much it took for the run, the source on which it was run, and so on. And here we see a parameter. We gave the parameter name as parameter 1 and its value, and we had two metrics, foo and bar. We can go to model metrics and we can see the matrix here and its visualization. We can also see system metrics here, but right now no system metrics has been recorded, so there is no data over here. And in artifacts, we don't see any artifacts. We tried logging artifact, but because the file was not available, so artifact is not available here. So let's go back here. Now let us try to remove this particular artifact, and I'm just going to create a file, experiment1.txt. So once it is created, I'm again going to go back here and I'll just run this again. As you can see, this time there are no errors, and in this particular run, the name of this run is glamorous qual 219. Let us go back here and try to refresh this and select our experiment test tracking server. Now we can see glamorous qual run is also available here, and the previous run is also available here, and this time it is successful. Let's click on this. We will see all the details again. We can see model metrics. System metrics is still not available because we have not added it yet. And in the artifact, we can see experiment1.txt file. There is an option to select these experiments. And once we select it, we will get an option to compare. So let's click on compare, and we can see some cool visualization over here. And we can select the parameter, and the matrix we have selected is foo. And we can see with parameter 1 and its value of foo is this. And we can see like the comparison between both the runs, the start time, end time, the duration it took. And here it will show the parameters used in both the runs and the matrix in both the runs, what was changed and what its value, and overall artifacts were there. So this way we can compare different runs. There are few folders available inside it. So one more interesting thing to note here is it has created this folder. This is some kind of ID, and this corresponds to the experiment. So this is experiment ID. We can go here, let's go to the experiment, and as you can see within experiment here also in the URL bar you can see this particular ID. So this is the ID of the experiment, and within that we can see there are two folders that got created. One is this one, another one is this one. So these corresponds to different run. Let's go back and let us select this together and click on compare so that we can see the details here together. So as you can see the run ID is 0AE D9E, 0AE and D9E. These folders will correspond to the runs that are happening within this experiment. And right now we don't have any model available here, so this particular part is empty. So this is ML runs folder, and within ML artifacts we can see particular experiment, and under that experiment we have a particular run, and within that particular run we have experiment1.txt artifact available. Okay, awesome. Now we have a fair understanding on how the folder structure looks like, how to run an experiment, how to compare them, fair understanding about many things. What I'm going to do is I'm going to run another experiment just to show you how it looks like. So I'm just going to copy this and put it here again, and I'm going to give it a name test tracking server and just the number 2, and let's keep everything as it is. I just wanted to show you a different experiment that is running. So let's keep everything same and run it again, and as you can see it is available on this particular URL. We can go ahead here and we can just click on experiment, and we have a different experiment available here. So within this experiment we have only one run because we just run it for one time only, and we can see everything available here: the model matrix, the artifact, and if I select all of them together I will have all the runs together here. We can simply click on all of them and then compare even the different run under different experiment together on the same UI. So this way we will be able to compare all the runs under different experiment. So this is really cool. And also we have this particular folder 0, and inside this we can see a meta.yml file. It has all the details, kind of metadata details like artifact location, creation time, experiment ID, last update, lifecycle stage, and so on. There could be more folders around it, and we also have meta.yaml file within a particular experiment which will have all the details of a particular experiment, and within a particular run as well we will have meta.yaml file which will have metadata about that particular run. And under this we will have different kind of folder, for example artifact, matrix, param, stacks. This will all be related to this particular run. For example, if you have any artifact related to this particular run, we can see it here. Matrix like foo, as you can see for this particular matrix we have the values available here, and everything is getting stored over here. We can see params as well, so parameter 1 and its value. So everything is getting logged and everything is available under this particular ML runs folder, and this is where of all the experiments are getting stored. So far we have seen many things about MLFlow, but now is the time to get along a real model training and prediction using MLFlow. So what I'm going to do is I'm going to clean up my previous ML runs, and I'm going to create a new file and give it a name, my first model.ipynb. And since I have deleted this, and if I go to experiments I will see nothing here because I have deleted all of them, so my tracking server will not have anything about it, so it will say something went wrong. So I'm just going to stop it and start it again so that the UI is available to me. And because I also created the ML runs folder which was not really required, so it has created it again on the next run. Okay, cool. So I'm going to start with a new file, my first model.ipynb. ipynb file, and here I'm going to create complete model training and prediction. So I'm going to import certain things, import packages. So let's import pandas as pd. Then we are going to use sklearn, and we are going to import data set from it. So we will be using a predefined or already available data set from sklearn, and from sklearn we are going to import dot linear model, import logistic regression, and again from sklearn we are going to import metrics, and we will be importing accuracy score because we want to log the accuracy of the model after training it with the sample data. And we are going to import none other than MLFlow. And from MLFlow models we are going to import infer signature. We will talk about this infer signature in the last section of this video, so don't worry if you don't understand anything here. So we have specified all the packages here, but we need to install all these in our requirement.txt file as well. So before that, let us go to our requirements.txt file, and here apart from MLFlow we need numpy, scikit-learn, pandas. So we will need these, and I'm just going to do again pip install -r requirements.txt. It is going to install all those things. Okay, great. So we now have that. Let us go back to our code. So before proceeding, let us have a look like what scikit-learn is about. The scikit-learn is one of the most widely used libraries for machine learning in Python. It provides a range of simple and efficient tools for data analysis and machine learning, including algorithms, for example, classification, regression, clustering, model selection, and pre-processing of data. It is free and open source Python library built on top of NumPy and SciPy and Matplotlib. Okay, so now we have imported all these required things. Let us go ahead and run this, and it is going to ask from which kernel should I run this from. So I'm going to select this one, the virtual environment, and it's running. It's trying to import packages. Meanwhile it is running, let us go ahead and try to add remaining things. Like we need to set the tracking server. So we are going to say mlflow dot set tracking URI, and we know it's localhost. The package import is also done. Setting tracking server is also done. Now the next thing is we are going to load the data set. So I'm just going to ignore this suggestion, and instead of this I'm going to take this in x comma y, and using datasets.load iris. So while loading the dataset, what I'm saying is return x and y and setting it to true. So I'm asking like return the x and y parameter and store them in these variables which I have set on the left hand side. So we are using iris dataset, which is already available in this particular scikit-learn package. So this has 4 features known as sepal width, sepal length, and petal width and petal length. So the output is kind of flower. So in machine learning, like you should know about this. So the iris dataset consists of 3 different type of irises: setosa, versicolor, and virginica. Petal and sepal length stored in 150 by 4 numpy nd array. The rows being the samples and the columns being sepal length, sepal width, petal length, and petal width. So this is just an example data set that we are using. So if you don't know much about it, don't worry. The objective here is to learn how to train the model and how to store and log the metrics in MLflow. So if you don't understand everything as of now, so it's completely okay. Now let's get back to where we were. So here, as I already explained, we are trying to load the data set and we are saying return x and y parameter, and we are storing this in x and y variable. And if you just want to see how they looks like, you can simply print x and you can see like this is how the array looks like. It has 4 values, and as we just saw, like 150 by 4 numpy nd array. So the columns are specifying sepal length, sepal width. So these are sepal length, sepal width, and petal length and petal width. Okay, and if you want to see what is y, so let's try to run this with y. So these are the 3 categories of the flower which we just saw here: setosa, versicolor, and virginica. So these are the 2 parameters that we are looking for. Now we are going to split the data into training and test dataset. So I'm just going to give the variable name as xtrain, comma x underscore test, ytrain and ytest. And I'm not going to specifically choose from the array. Rather, what I'll do is I'll use the function train test split, and from the xy I'm giving test size as 0.2, that is 20%. And for the simplicity, I'm just going to remove this random state for now. So I'm allocating 20% of the input to the test size. Now let's go ahead and run this one. It is giving an error. Trend test split is not defined. Okay, now it is giving an error because it is not defined. So we need to just import this one from sklearn model. We need to import this trend test split. So that I have done here. Let me just copy and put it on the top. Okay, here we have imported it. Now let's run it again. That's fine. And now we should not see the error. Let's go ahead and run it again. Okay, perfect. It is now running. Now the next thing we are going to do is define the hyperparameters for model. So we are going to use certain parameters. So as we have seen above, so what we have imported is logistic regression. Logistic regression class implements regularized logistic regression using liblinear library, Newton CG, SAG, Saga, LBFGS solvers. So basically in scikit-learn we have already seen. So scikit-learn supports many algorithms, for example classification, regression, clustering. So here we are using regression, right? So based on regression we need to use certain params. So just look for logistic regression parameter, and for logistic regression we will see a lot of parameters available. So for example we have penalty, we have dwell to set to false, multi-class, and so on. All these parameters are defined here. We don't need to actually go much deeper into all these parameters as of now, but for your reference, like you can go here and study all the parameters. For example, we are using solver. So solver is like an algorithm to be used in optimization problem. Default solver that will be used will be LBFGS, but we can choose different solver, for example Newton CG. So we can get all the parameters from here. For now I'm going to use certain parameters. For example, let us use penalty, and let's use the value as L2. Let's remove this C. We are going to use the solver as LBFGS. Max iteration is set to 100. Let us set to 1000. Then we can use multi-class as auto, and also use random state. Okay, cool. So we have our parameters defined now. Now we will be training the model based on these parameters. So next step is train the model. So we are going to train the model using logistic regression algorithm, and we are giving it all the params that we have defined here. Now we are going to fit the data to this model. So I'm writing the function lr.fit and giving the variable xtrain and ytrain, which we have got by splitting the data set into the training data set and the test data set. So I'm just going to give xtrain and ytrain for the training purpose. Now let's execute this one. Okay, it is successful. So as you can see, like logistic regression, max iteration, random state and everything. Okay, now the model training is done. Now we need to do production on the data set. So predict the test data set. So since X was the input, so as you can see that my co-pilot is already writing the code for me. So let me just complete this one. So what we are going to do is we are going to predict the Y, and the Y is nothing but the three different type of irises, that is setosa, versicolor and virginica. So it is going to predict that, and we are going to use the predict function from our trained model based on the X test. So X test is nothing, which we have already seen here. X test is nothing but the input for test purpose. So we allocated 20% of the input from the data set as the test data set. And based on that, we are going to predict Y. Okay, awesome. Now it must have predicted. So let us go ahead and just print it. And let's see what output it gives. Okay, so now it is giving us the output like this. So based on the test data set, it is giving us the Y out of 0, 1, 2. So let us also try to print the X test just to see what all values are there and just run it. As you can see, the X test is all these values. So for the very first one, we are getting 2. So let us try to print the Y pred again. And let's run this. So for this particular first input, we will get the output as 2. So this is how the prediction is going on. Okay, now we have predicted from the data set. Now we need to see the accuracy. So Copilot has again suggested the whole code for me. So accuracy is nothing. We can get it from the function accuracy score and based on the Y test and Y pred data. And let us go ahead and just print this accuracy and let's run this. So as you can see, like we have got 96% as the accuracy. So our model is predicting the value 96% accurately. So this is really a good figure, I think. Now we have got the accuracy, we have done the prediction. The next thing we need to do is we need to tell our MLFlow tracking server. So MLFlow dot set tracking URI, and we need to just specify it. Then we need to create the experiment. MLFlow.set experiment, and we can give it a name called my first MLOps experiment. Then we need to start the MLFlow run. So with MLFlow dot start run, I want to log many things. So it has auto completed things. For example, we are logging the model, okay, and we are using the signature as infer signature. So infer is an MLflow model signature from the training data input and model prediction output and parameters for inference. So this signature represents model input and output as data frames. So this is nothing but the input that we are giving and the output we are getting. So this is representing model input and output as data frame. So this is all the signature is about. And the next thing we are logging is accuracy, and we are also logging the parameters. So the parameters we have seen, right? The solver we are using, the multi-class we are using, and then we are logging the param features like xtrain columns, and we are logging the target param, that is ytrain.name. Okay, great. So we have all the things that we want to log. So I'm just going to run this. Okay, we have got an error. numpy.ndArray object has no attribute column. So we are trying to log the column as well. So the copilot doesn't know like columns doesn't exist. So I'm just going to remove this. No problem in this particular thing. Let us just remove this and run this again. Okay, the experiment is successful. Let us go back to our MLFlow and refresh this page, and we can see my first MLOps experiment is available here. And the first run was unsuccessful because of that error. But after that, like in this particular run, skittish fox, this is available. So like we are using the parameters penalty as L2, random state 42, solver is LBFGS, max iteration is 1000. So the more iteration you have, the more accuracy and the more better prediction you can get. And your model will be able to predict the result in much accurate way because you are training it again and again, right? So the more iteration you give, the more experience the model will become. And the accuracy has been logged as 0.966. So here is the accuracy graph, no system metrics, and artifact. We have many things like ML model. So it has all the details like artifact path, the environment we are using, the virtual environment, we are using sklearn, and the model.pickle file is also here. So a model.pickle file is nothing but it is a serialized machine learning model. In Python, serialization refers to the process of converting an object such as machine learning model into a byte stream so that it can be saved to a disk. So ultimately, like .pickle file is nothing but your model return to a file in a serialized fashion. And the extension is PKL and it is pronounced as pickle. Then we have Python environment YML, like dependency are getting resolved through requirements.txt. We have requirement.txt. So all these things are getting logged because we are using log model and it is logging all these things. Now let's copy this params again and we are going to run this with Newton CG solver. Now we will train the model again. Now we will do the prediction again. And after that, we are going to get the accuracy. So I'm just copying again all those things and try to run this again. Now let's run this and let's see what the accuracy we get. Okay, again we are getting 96% accuracy. So this looks almost similar. So let's try to remove certain things or change certain things. For example, I'm just removing the penalty. So I'm just trying to reduce the max iteration to 1 because I just want the accuracy to be changed, or it should change with respect to what we have seen so far, because the low iteration, the low the accuracy will be. So let us go ahead and try to run this. And okay, so now we have accuracy of 66%. So this is like 30% reduction in the accuracy. Now let's go ahead and log this. So I'm just going to copy everything that we had before and I'm going to just log everything, and this time I'm going to give the experiment name as my second experiment, and let's run this. Okay, the experiment is available here and the name of this run is lyrical bore. Let's go to the UI and see the experiments. So the second experiment is available here and all the details are mentioned here, and the accuracy we have is 66%. So I'm just going to compare both the run under different experiment and let's compare them. So we have this beautiful graph available here and we can actually compare like the duration it took. So the second iteration took 1.8 seconds and the first iteration took 1.6 seconds, and the max iteration was set to 1 in the second experiment. And like we are using Newton CG in the second experiment and LBFGS in the first experiment. So using different solvers, we can see like which one is predicting more accurately, and based on all these parameters, we can actually decide which model and which parameters are working well with our model and predicting quite correctly. We have compared the two runs from our two experiments and we have some good data available here. And if I go to my second experiment and go to artifacts, we have the whole model packaged here, And if I just simply click on model, so we can see the path available here, MLFlow artifact, and this is nothing but the experiment ID, and under that we have the run ID, under that we have artifact and the model. So this is similar to what we have seen here in ML runs. We have particular experiment, so the experiment, this one is 236, so this is the one 236, and under that there is a run B33CB, so that's B33CB, and under that we have artifacts. So we have artifacts, metrics, and other params, everything available here. So basically it is packaged. Now MLFlow model, the code snippets below demonstrate how to make prediction using logged model. You can register it to model registry or version control. So basically you can package this and store the model in the model registry, that we are going to see something later on. But for now, the interesting part here is it is saying us validate the model before deployment. So we have created the model, we have run the experiment. Now we can validate our model based on certain input and see the output. So it has given the code. So it is saying run the following code to validate the model inference works on the example payload prior to deployment. So let us copy this one, and we are going to actually run this, but let's try to understand this. So basically from MLFlow models, it is importing validate serving input, and the model URI is nothing but it is taking from your local, that is the experiment ID. Sorry, it is the run ID, not the experiment ID. And from MLFlows, it is trying to import convert input example to serving input, and then define input example via assignment with your own input and validate serving input. So right now, like, we don't see any example here. So what I'm going to do is I'm going to log the example as well, so that this code which is generated will also include the input. So in the log model section, I'm also going to include input example with xtrain, and let us go ahead and run this one. Okay, in the second one we should see this particular one, and let's go to artifact. Now as we can see in the validate section, we have the input available as well. So based on this input, it is going to validate the serving input. Now let's go ahead and run this particular code and let's see how it looks like. I've just copied this and I'm going to run this here. So we have already seen what this code is actually doing. This is a bit long. I've already explained the model URI. The serving payload is taken from the input example which we already logged, and at the end it is using the function validate serving input. So as you can see, this is a helper function to validate the model that can be served, and provided input is valid prior to serving the model, and it takes the argument model URI and the serving input, and it returns the prediction result from the model. So let's go ahead and run this and let's see what we get. So yeah, we have got the prediction output, that is the type of the flower based on the input data. Okay, great. Now another thing I want to show you is loading the model for prediction as a generic Python function model. Now let's load the model in a variable called loaded model, and here what I'm going to do is MLFlow.pyfunc. So basically I'm using pyfunc to load the model as a generic Python function. So the model will be available as a function to be accessed by giving certain arguments for the input and get the output for the prediction, and it is taking model URI. So now we have loaded the model. Let's try to get the predictions. So we are going to say a loaded model dot predict. So we have loaded the model into this variable, and on this we are calling the function predict using xtest, the test data set we have. And let's try to load the data set to iris features variable datasets dot load iris dot feature names. Let's try to make the variable name more intuitive by adding names. Now let's try to get the result. equals to pd dot so results equals to pd data frame x test. So we are going to load the result as pandas data frame, and we are giving the data like x test and the column with iris features names. So the column name in the pandas data frame will be based on iris features names. And the result of actual class will be y test, and result of predicted class will be predictions that we are getting from this predictions variable. Now at the end, let us just display the result. We are good, we can run this now. So let's run this, and yeah, we have got the output. So we have got the sepal length, sepal width, petal width, and the actual class and the predicted class. So for example, like for this input, the actual class was 2 and the predicted class is also 2. So it has predicted it right. And in the second case, all these input, the actual class was 1, but the prediction was 0. So this is kind of wrong. So this is a wrong prediction, and so on. So we can now actually see the predictions and the data in much more intuitive way, and we can understand the prediction that is happening here. So that's all for this video. I hope now you have a fair understanding like how the model is working, how the predictions are happening, how we are using the required model, and how we can package the model, how we can validate the model, how we can infer the model. For example, like we are actually seeing the input and the output against it and the actual value as well. So we know like where our model is giving wrong answers and so on. Okay guys, so now we have created the model, trained it and predicted the output, also packaged our model into data frame and visualized the data frame in much more intuitive way. The next thing now we can do is register our model. So once we are sure like the model is working fine and it is validating against the input, then we can use that model in the registry for further predictions. So let me go back to the UI, and here for this particular experiment, if you go to artifact, like we see a button here, register model, because we have not registered this model in the registry. So registry is nothing but a centralized place where you can keep your model and the model can be stored in versioned manner. For example, you can give notations, labels to a particular version of your model, and then later use that particular model with the corresponding version to predict based on certain inputs. So consider model registry is similar to Docker registry, where you have different Docker images of your application and different tags based on environment, based on a specific version like v1.21, something like that. So as of now, I can go ahead and manually register this one, and I just need to select a model, or I can create a new model, give it a model name, and then simply click on register. So let's give it manual model registration. So I'm just giving this model name manual model registration, and I'm just registering this. So this is registered, and we can see like a manual model registration v1. So it has given the version v1 and it is registered on this particular day. If I go back here on model registered, so this will take me to a different UI, and flexible govern deployments with new model registry UI. It is just suggesting like previously it looks like this, now it looks like this. So I'm just saying try it now. I can go ahead and see. So I can see all the registered model here and their version. If I go here, I can see this particular version. I can have different version among these. So this is manual registration and the model is available here in the model section. Now let us go back to our code, and here we are going to register the model through code. So as we saw, we were writing the accuracy and the accuracy was 66%, I think. So which was not a good one. So let's not register this particular model. We are going to register the one in which the accuracy was 96%. So here when I'm logging the model, I'm just going to say registered model name, and I'm going to give it a name, registered through code, so that we can make out like this was registered through code. And I'm just going to run it again. Okay, here on the logs also you can see created version 1 of model registered through code. So if we just go to model again and refresh this one, we have registered through code. Sorry for the typo here, but yeah, the main objective is to understand this is getting registered through code, and this is version 1. I can simply run it again and there will be another version available. Let's refresh this. As you can see, like version 2 is the latest version, and if I click on it, we can see both the versions available here. Now what I need to do is, suppose if you ask me to predict something based on a particular model version. For example, if you ask me, hey Ajit, let's predict using the version 1 model. So now how can we use this particular version 1 model? Let's go ahead and see. So now we are going to do inference using the model from model registry. So we need to import MLFlow.sklearn, and then we need to give the model name. So it is registered through code because we have registered it through code. This is the name that is also present here, registered through code. And then we need to give model version. So I'm going to use the latest one. So by using latest, we will be using version 2. Next thing is we need to provide model URI, and here the nomenclature of model URI will be like get models from model name and then the model version. Now we are actually going to load the model. So we are going to load it in model variable. It will be mlflow.sklearn.load model, and we are going to load it from the model URI that we have just defined in the previous step. And at the end, we are just going to print the model. Let's go ahead and run this. Okay, so this is the output, and we have got the output like this is a logistic regression, and max iteration was set to 1 and multi-class to auto, like with all the parameters it is showing. Let's also print the model URI. So as you can see, the model URI is set to registered through code, and we are using the latest one. Okay, great. So now let's do the prediction. So let's define a ypred from model predict, because we have loaded the model, so we can use that one. And let's give this variable new, and then let's simply print this out. Okay, so now it has predicted and given the output like this. So it is working and it is predicting from this particular version of the model. So now we have completed the overall workflow using MLFlow of the whole MLOps lifecycle, and we have completed almost each and every part of using MLFlow, like creating the data set, loading the data set, tracking server, training the model, prediction using the model, running different experiments and runs using different parameters, logging metrics, and registering the model, validating the model based on different registered model and based on different inputs. So now you can say yourself you are an MLOps engineer, because you have really fair understanding by now about MLOps.